Hi everyone. In this video, we will discuss the wastewater treatment and technology. At the end of this session, students are able to differentiate the characteristics of domestic wastewater and industrial wastewater, understand the degrees of treatment, calculate and understand problems related to pre-treatment, calculate problems related to primary treatment, and understand the concept of secondary and tertiary treatment. Now, to start with, let us discuss the characteristics of domestic wastewater. Fresh aerobic domestic wastewater has been said to have the odor of kerosene or freshly turned earth. Aged septic sewage is considerably more offensive to the olfactory sense. So when we say of olfactory sense, it refers to the sense of smell. Fresh sewage is typically gray in color. Septic sewage is black. This color results from the precipitation of the iron sulfide. Wastewater temperatures normally range between 10 and 20 degrees Celsius. In general, the temperature of the wastewater will be higher than that of the water supply because of the addition of warm water from households and heating within the plumbing system of the structure. These are the typical composition of untreated domestic wastewater. So we have here the alkalinity, the BOD5, the chloride, the chemical oxygen demand or the COD, the suspended solids, the settleable solids, the total dissolved solids, the total kaldal nitrogen, total organic carbon, and total phosphorus. So we have here new constituent, the COD, the total kaldal nitrogen, and the total phosphorus. So this chemical oxygen demand is measured by a COD test to determine the oxygen equivalent of the organic matter that can be oxidized by a strong chemical oxidizing agent. Normally, the chemical oxidizing agent here is the potassium dichromate in an acid medium. The COD of the waste in general will be greater than the BOD5, of course, because more compounds can be oxidized chemically than can be oxidized biologically. The total kaldal nitrogen is a measure of the organic and ammonia nitrogen in the wastewater. So this total kaldal nitrogen gives a measure of the availability of nitrogen for building cells as well as potential nitrogenous oxygen demand that will have to be satisfied. And this phosphorus may appear in many forms in wastewater, among which are the orthophosphates, polyphosphates, and the organic phosphates. So we also have here the weak concentration, medium concentration, and the strong concentration. Now let's move on to the Environmental Protection Agency's conventional and non-conventional pollutant categories. So for the conventional, we have the biological oxygen demand, the total suspended solids, oil and grease, oil from animal and vegetable, oil from mineral, and the pH. While in non-conventional, we have the ammonia, chromium, chemical oxygen demand, COD over BOD7, fluoride, manganese, nitrate, organic nitrogen, pesticide active ingredients, phenols, total, phosphorus total, and the total organic carbon. Now let's move on to the characteristics of industrial wastewater. So the industrial wastewater processes generate a wide variety of wastewater pollutants. The characteristics and levels of pollutants vary significantly from industry to industry. So if we say of a petroleum industry, it has a different industrial wastewater component or composition compared to the manufacturing industry. The Environmental Protection Agency has grouped the pollutants into three categories. We have the conventional, non-conventional, and the priority pollutants. These are the examples of industrial wastewater concentrations for BOD5 and the suspended solids. So for ammunition, it refers to the weapon or the materials for weapon system. The BOD5 is 50 to 300 milligrams per liter, and the suspended solid 70 to 1700 milligrams per liter. For the fermentation industry, the BOD5 is 4,500 milligrams per liter, while the suspended solids 10,000 milligrams per liter. In slaughterhouse for cattle, we have the BOD5 of 400 to 2,500 milligrams per liter, and suspended solids of 400 to 1,000 milligrams per liter. For pulp and paper industry, we have 100 to 350 milligrams per liter of BOD5 and 75 to 300 milligrams per liter of suspended solids. For tannery, It's 700 to 7,000 of BOD5 and 4,000 to 20,000 milligrams per liter of suspended solids. Now let's move on to the examples of industrial wastewater concentrations for non-conventional pollutants. For the steel mill industry, which is the coke byproduct, the pollutant is the ammonia and produces the concentration of 200 milligrams per liter, organic nitrogen of 100 milligrams per liter, and phenol concentration of 2000 milligrams per liter. Now for metal plating industry, the pollutant is chromium 6 with a concentration of 3 to 550 milligrams per liter. And in nylon polymer industry, we have the pollutant of chemical oxygen demand, and TOC. The chemical oxygen demand has a concentration of 23,000 milligrams per liter. For TOC, we have 8,800 milligrams per liter. For plywood plant industry, specific for glue waste, the pollutants are COD, phenol, and phosphorus. For COD, we have the concentration of 2,000 milligrams per liter. For phenol, we have 200 to 2,000 milligrams per liter. And for phosphorus, we have 9 to 15 milligrams per liter. And this is the degrees of treatment specifically used in many cities. As you observed, the degrees of treatment consist of 4 parts: the pre-treatment, primary treatment, secondary treatment, and the tertiary treatment. For pre-treatment, it consists of bar rack, grit chamber, and equalization basin. For primary treatment, it has a primary settling. For secondary treatment, biological treatment, and the secondary treatment specific process. And for the tertiary treatment, we have the tertiary waste treatment prior to the receiving body. So the purpose of pre-treatment is to provide protection to the wastewater treatment plant. Some of the components have rocks, debris, and stones. So to protect the equipment of the wastewater treatment plant, let's say for example the pumps, we need to have this bar rack and grit chamber to eliminate those large particles and to protect the pump from clogging into the strainers and to the suction line. Well, in some municipal plants, the equalization step may not be included. The major goal of the primary treatment is to remove from wastewater those pollutants that will either settle or float. Primary treatment will typically remove about 60% of the suspended solids in raw sewage and 35% of the BOD5. Soluble pollutants are not removed. At one time, this was the only treatment used by many cities. Although primary treatment alone is no longer acceptable, it is frequently used as the first treatment step in a secondary treatment system. Now for the secondary treatment, its major goal is to remove the soluble BOD5 that escapes the primary process and to provide added removal of suspended solids. Secondary treatment is typically achieved by using biological processes. These provide the same biological reactions that would occur in the receiving water if it had adequate capacity to assimilate the wastewater. The secondary treatment processes are designed to speed up these natural processes so that the breakdown of the degradable organic pollutants can be achieved in a relatively short time. Although secondary treatment may have removed more than 85% of the BOD5 and suspended solids, it does not remove significant amounts of nitrogen, phosphorus, or heavy metals, nor does it completely remove pathogenic bacteria and the viruses. In cases where secondary levels of treatment are inadequate, additional treatment processes are applied to the secondary effluent. For the last process, the tertiary treatment process, it involves chemical treatment and filtration of the wastewater, much like adding a typical water treatment plant to the tail end of the secondary plant, and they may involve applying the secondary effluent to the land in carefully designed irrigation systems where the pollutants are removed by a soil crop system. Some of these processes can remove as much as 99% of the BOD5, phosphorus, suspended solids, and bacteria, and 95% of the nitrogen. They can produce a sparkling clean, colorless, odorless effluent. Although these processes and land treatment systems are often applied to secondary effluent for tertiary treatment, they have also been used in place of conventional secondary treatment processes. That's all for now for the characteristics of domestic and industrial wastewater. For the succeeding topics we will have on the next, lecture video. Thank